Hello everyone, welcome back to the channel. Today we are solving LeetCode 229 majority element 2. So this problem is one of the most famous interview questions because it introduces the extended Boyer-Moore voting algorithm, and if you have already solved majority element 1, you might think this problem is very similar. But today, instead of finding an element that appears more than n by 2 times, we are finding the element which appears more than n by 3 times. This is the difference, okay? So in this video we want to memorize the algorithm. We will derive it ourselves. By the end of this video you'll understand exactly why it works. So if we try to understand the question, let's understand it carefully. So we are given an integer array. Our task is to return all the elements whose frequency is greater than n by 3. So see, as we can see, this is like a example array 3 to 3. So number of elements is 3. So 3 by 3 is 1. So we need the elements who appear more than 1 times in this array, which is 3 only. So output would be 3. And in this 1 by 2, the size is 2. So 2 by 3 would be like any element greater than 0 or something. So yes, 1 and 2 both, they are unique, but yes, they are the output. So output must be a vector. So this is the problem, and what it wants is that we solve it in a linear time in of one space. So this is the tricky part, and it's the main algo also, the Boyer-Moore algo extended. So okay, now what we can try is, before moving to the brute force approach, let's move to the whiteboard first. If we come to the whiteboard, so okay, what we can think of in brute force is for every element, like 3 2 3. Okay, so for every element we can count its frequency, and if frequency is greater than n by 3, we can store it in n vector or anything. Yep, vector of course. So how do we count frequency? Again, traverse the array. So for every element we again traverse the entire array. Like if we are counting for 3, we would traverse it again, and we are doing it for 2, we have to traverse it again. So if array size is n and the outer loop will run for n times, this whole would be like for n times, and an inner loop also would be run to count the frequency, so one more n. So the overall time complexity would be n into n, of course, because it's a nested loop, and the time complexity would become n square of n square. Okay, so this is not feasible, and yes, we can improve it definitely. So another solution that comes to your mind when I say, when I talk about the solution that we used in the first better approach in majority element 1 also. So what can we do is, instead of traversing like this nested loops, we can do what, we can have a map here. In the map, let's say we have 2 also, like as key we have 2 and 3. So we can store in the map their frequencies, right? Just 2 have one frequency and 3 have 2, like 3 appears 2 number of times. Okay, so how we can store it? We can just traverse it once, and while traversing it we can store it in a hash map. Okay, and then what we can do is, from the hash map we can run another loop on hash map, and we can check who is greater than n by 3, and we can push it in the vector. It's easy enough, right? So it's a better approach. We talked about the brute, which was a nested loop, and we talked about better, which is hash map plus vector. Okay, so yep, if we try to code this hash map approach, it's not like that much difficult. We are talking about, this is a good approach, but not the most optimal one, because its time complexity would be of n, of course, because we are not using any nested loop, and space complexity would be of n also, because we are using an extra data structure, which is maps. So but the question wants that we take it to the of one space, right? So yes, we will move to of one space, but this is also a good approach to explain to the interviewer. We can start with the brute force approach, then we can come to this approach that we are doing now. So what we can do is, we can have an unordered map which have integer as both key and value pair, and a vector for the answer, of course. So a vector would be there, and we will run a loop This is like basic, but yes, optimal at the same time. So we can run a loop on the vector as nums, and we can store it in map with the key as the element, and we can increase whenever it finds it, right? So this was to store in the map, and then we can run a loop on the map itself, right? We can run the loop on the map, and from map what we can do is that if it dot second, the like the value, of course, right? Value is the frequency. So the frequency, if the frequency is greater than nums dot size divided by 3, like n divided by 3, you can store it in another variable, of course, but yeah, it's the same thing. So this was the size, and size divided by 3 was the condition in the question, right? So we use it that if it is greater than this, then what we can do, we can push back into the vector. And what we would push back, we would push back the value, the first, sorry, my bad, the key will push. We check the value first, and then we push the key if it satisfies, and then finally we would return the answer. So this is a better approach. It has a time complexity of n, and we are using extra data structure, so space complexity would be of n. Like we need of 1, so this is not the best approach, of course. So now we will move to the best approach, and yep, it is a bit difficult to understand, but if we have done the normal Boer mode in majority element 1, it would be much easier for you to understand. But yes, it's a bit tricky, so please listen to it carefully. Now we will move to the most optimal approach for this question. Okay, so now we will move to the optimal approach. So before moving to the optimal approach, let's observe a thing. Okay, we are on the optimal approach now. Yep, so observe a thing. If like we are finding, we are finding more than n by 3 occurrences of an element, right? So if the number of elements is, let's say, 9, okay, so then n by 3 would be 3, right? And if n by 3 is 3, so the majority elements would be like 3 or more than that, right? So if n by 3 is 3, so can there be like more than, like greater than 3 elements, like if we can say elements should appear 3 times, right? So if 2 elements appear 3 times, so it would be 6 elements, and if appears one more time, then it would be 9. It will correct 9, okay? But if we take like if all 3 elements appear like 4 times, because we need greater than 3, right? So if all appear 4 times, then it would be 4 plus 4 8, 4 plus 4 8, and 8 plus 4 12. But 12 is not, like, it's not possible, right? Elements are 9, and we are saying that total elements come out to be 12 if 3 elements are like majority elements, but it is not possible, of course. So basically what I am trying to say is that if n by 3 is a number, any number, so the number of majority elements cannot exceed that number, right? 4 plus 4, 2 are okay, 2 majority elements are okay, they can be possible, but not the third one, right? So yep, this is the crux. The whole algo is based on this crux, right? If we take another example, if we say n is equals to 12, right? So what would be n by 3? N by 3 would be 4, right? So if we have to satisfy the condition, so the number of elements which is the majority element, it should be greater than 4, which is 5. This should start with 5. So if 5 and 5, 2 elements with 5 occurrences is there, it is right, it will be 10. But if one more occurrence is like coming, it is not practically possible, we are just assuming it, so it would be 15, but it is not possible, practically not possible. So this is the main crux of the problem. This is the main rule. So from this only we will be moving to the real poem or algo. In majority element 1 also we followed this only. In this we will have 2 candidates and 2 counts. In that we had only 1 candidate and 1 count, okay? So we'll understand it in detail. So the intuition is, yes, there can be at most two majority elements. Okay, if we are talking about this n by 3, that we need greater than n by 3. So here's the challenge: how do we know which two numbers to keep? So let's think, suppose the array is 1 2 3. Let's say the array is, let me erase this extra things. So if we say the array is 1 2 3, okay, erasing this. So okay, we are saying array is 1 2 and 3. Okay, so if the array is 1 2 3, so does any element appears more than n by 3 times? N by 3 would be 3 is here, so 3 by 3 is 1. So greater than 1 would be 2, but no element is appearing 2 times, right? Everyone is unique, everyone is appearing only 1 time. Now let's take another example. 1 2 3 1 1. Okay, so here although 2 and 3 appeared, like 2 and 3 appeared, but they could not survive because 1 kept appearing again, right? What we need majority element, right? So yep, 2 and 3 appeared, but they couldn't survive because 1 kept appearing again. So this gives an important idea that whenever we see 3 different numbers, we can cancel one occurrence of each, right? Like one, let's assume there's a count 1 1 1, but then again 1 comes and again 1 comes. So yes, like they can't be the majority elements, right? So this is the basic approach. So the real majority element still remains majority. Like if it is a real majority element, like 1 is the real majority here, so yep, it will like maintain its majority all the way through it. Okay, so what do we store exactly? Since there can be at most 2 majority elements, we'll maintain candidate 1, candidate 2 along with count 1, count 2. So initially candidate 1 does not exist, candidate 2 does not exist, and count 1 and count 2 would be 0. So yep, we will understand it like with a dry run, detailed dry run, then you can have the idea like how we are doing it exactly. So now let's move to the dry run. Okay, so now we are at the dry run part. So we'll try to understand like what is the basic crux of this. So we will maintain 4 variables, candidate 1 and candidate 2, and count 1, count 2. So we'll try to finish it in one pass. The basic idea is this, because we need of 1 space complexity. Okay, so yep, in the start we will we'll start the variables count 1 and count 2 from 0, and candidate 1 candidate 2 does not have any like candidates, right? So candidate means we are trying each and every candidate. Candidate means each and every element, 1 2 3. Okay, we'll try and test all of them. So we'll try to run on this array, basically this array. Okay, we'll try to do on this. So let me, yep, we'll write the values, that what will be values after each pass, and we'll maintain a pointer here. Okay, so we'll start with the loop. So first it is on 1, of course. So yep, if we are at 1, okay, so current is 1 and count 1 is 0, and if count 1 is 0, so yes, candidate 1 is like no one right now. So we will start by doing the candidate 1 as 1. Okay, we are assuming that candidate is 1 to be the majority element. Okay, so if we assume it 1, so yep, count will also increase from 0 to 1. Okay, so now we will move to the next element, that is 2. So if we move to 2, candidate 1 cannot be 2 because it is already 1, and we can like put it in the candidate 2 because it is empty as of now. So if current is 2, so it does not match candidate 1, we cannot increment candidate 1, so we will add 2 in the candidate 2 part, because yes, we can make 2 candidate because it is free, and count 2 will also increase by 1. Okay, so again, if we try to move to the next element, it is also 2, so it matches candidate 2. It doesn't match candidate 1, but it matches candidate 2, so the count of candidate 2 would increase to 2, of course, because we found another one. Okay, fair enough. Now we will move to the next position, which is 3. Okay, so if we move to 3, it does not match candidate 1, it does not match candidate 2. So what we will do in such a condition, if it does not match any of them and the counts are positive, so this means 3 different elements have been appeared, right? We got an idea that yes, 3 different elements have started to appear. 1 and 2 were there and a new element came out to be here. Okay, so then what we can do, yes, this can also be a candidate, right? So we'll start decrementing our counts of both the elements. So of 1 it will become 0 and for 2 it will become 1, right, as we discussed before. Okay, so current state is this, and 3 does not become a candidate. Instead it cancels both existing candidates, because yes, yet 2 and 1 have more chance than 3 to become the candidate. 1 has not, like 1 has become 0, but yes, still it has more chances. Okay, so now if we move next, where the pointer would be, it would be at 2. So 2 matches the candidate 2, so yes, we will increase the count of 2 again to 2, because it was 1, so it will increase to 2. We do not have to do anything else. Count 1 is 0 and candidate is also 1 still. Okay, so then after this we will move to 1, and if we move to 1 we will increase candidate. So when the vote became 0 of 1, like it lost all the chances to become the majority element, but yes, it regained its chance, and will make it 1 again. And if we move the pointer once again, then also again the increment would be made, it will become 2. So the current condition is candidate 1 is still 1, candidate 2 is still 2, and count 1 is 2, count 2 is 2. Okay, so now last the pointer would point at 3. Okay, so 3 is not here, not here, not candidate 1, not candidate 2, so it will again cancel both the parts. So count 1 will become 1 and count 2 will become, candidate 2 will become 1. Okay, so now the traversal finished, and the first pass result would be candidate 1 is 1 and candidate 2 is 2. So are these automatic the answers? No, there are only possible candidates. Now we will verify them. So now what we will do, we will reset both counts and count frequencies of candidate 1, and then we will count frequencies of candidate 2. And if the array size would be 8, okay, so it is 8 here, yep. So if the array size is 8 and by 3 would be 2, so condition would be like in the last we will check. Okay, so what we basically did was, in a very first pass we found that which are the possible candidates. We had 3 elements, right? So which are the possible candidates? We found out 1 and 2. Now what we will do, we'll do the main part. We have not taken another data structure, like the space complexity is still of 1, right? So yeah, this was the basic idea. Loops would be still 2 because another loop would be needed to find the frequencies. So yep, we will reset the both counts. We can okay, so we can erase this part now. We found our candidates, right? Just a sec. We found our candidates. Okay, we can reset it here. It's again 0 and count of 2 is again 0. Okay, now what we'll do, we will again we will run a simple loop on the whole array, on the 8 array, and we will compare n by 3, as we know, like num size by 3, and if they are greater than n by 3, then we will return count 1 of 1 would be frequency would be 3, right, after the traversal. And for 2 it would be, 2 is how many times? 1 2 3, it is also 3 times. Okay, so we are just doing it for verification, and both the frequencies are greater than n by 3, which is n by 3 for this array would be 8 by 3, and it would be came as 2. So yep, it is, both are greater, so the final answer would contain 1 comma 2. This would be the final answer. So talking about the time complexity is still we can say of 1, but the main part was space complexity. We maintained it to of 1, which the question was asking. So yep, this was the main point, and now we can move to the code part and we can understand it there more clearly, at what is the time complexity and how we are writing the code exactly. So yep, let's move to the code part. Okay, so now the final code part which is like now much easier than we would have thought, because we have understood the approach using all the variables, which is candidate 1, and it would be 0 in start. We can introduce candidate 2, which is 0 again. We can introduce count 1, which is 0. We can introduce count 2, which is also 0. Okay, so yeah, these 4 variables are the start points, and then we will start our first traversal, which would be in the nums array, and in this there will be 4 conditions, 4 or 5 conditions. So if the n, so the n if is equal to, we can say candidate 1, as we saw, it will be not be equal, because in the starting it would not be, but yes, it's a condition in between. Okay, so if it is so, we can simply increase the count of that candidate, and else if same type of condition, if it is equal to candidate 2, like, okay, so it's basically obvious that if it is equal to candidate 2, we will increase its frequency. And another condition would be if we are just starting, like the count 1 is 0, which will be in the starting condition, of course, when we will try the first candidate. So in the else if condition, we can find here what would be if the count 1 is equal to 0. Okay, if the count 1 is equal to 0, what we can do, we can firstly assign the candidate 1 that, okay, you become n, basically, right, which is the current element, and the count 1 would start to increment, it will become 1. Okay, so same like this, if we have count 2 as equal to 0, if we have the space available, so we can assign to it also. So candidate 2 would become n here in this case, and count 2 will become 1. We can start incrementing it. Okay, simple enough, right? And if the condition came out to be that it is not equal to both the candidates, as it became with the 3 part when we were like, we assigned already to 1 and 2. So if this condition comes, okay, this condition comes, so we can do count 1 minus minus, both will be decremented like 1 time. Okay, so this is the last condition. So this was the first traversal, right? And this we just calculated or find out that what are the possible candidates for our majority element, right? And now we will verify it. So before verifying, what we will do is we will assign count 1 or again 0, and count 2 also again 0. So we do not need to write int, of course, because they are already defined. So count 2 would also become 0. Okay, now what we will do, we will do another traversal, and in this traversal what we will do, that if n is equal to basically candidate 1, okay, now we have it num as num. So yep, if num is equal to candidate 1, which is our 1 for this use case that we discussed, then you just increment the count. Yes, just increment the count, and we can copy this condition for our else part, that, okay, else if we can say, so if the num is equal to candidate 2, then you increment count 2 instead of count 1. Okay, now we have real frequencies, and after this traversal, what we will do, we will build the answer, final answer. Okay, so yep, this would be our final answer. This we will make an vector, and we'll finally find out that if the count 1 is greater than nums dot size, which we checked the main condition by 3, okay, if it is greater than this, then we can push back it, right? We can push back it in the array candidate 1, right? And we are verifying, basically we are just verifying, we are not doing anything else, we are just verifying. And another condition would be that if count 2 satisfies the condition, then we can push the candidate 2. Okay, and final, we can return the answer. Okay, let's try and run this. So yep, if we talk about the complexity that we have already discussed also, so here comes an error. Okay, no problem. Okay, so if n is equals to candidate 1, here would come 1. Okay, so yeah, talking about the time complexity, what would be, this is one loop and this is another loop, so we have two loops basically here, right? We have two loops here. So if we have two loops, what we can do is of n plus of n, it will basically become of 2, and we will drop the constant and it will become of n basically. And the space complexity, we are not using the map now, so it would become of 1, which was the target. So this was the whole problem, and this was basically the idea of extended Bohr algorithm, which is very important if we talk about, like, if you ever think of majority element problems, one or two, this should come to your mind. The candidate count approach, in majority element 1, it just uses one candidate and one count, and in this we use two. Okay, so this was basically in today's video. If you like the video, please subscribe to the channel, and thank you so much for watching.